Generation 1. This was the very first real Wi-Fi generation, based on that original IEEE 802.11 standard, the one approved back in '97. It worked in the 2.4 GHz band and, well, it supported only 1 or 2 megabytes per second. So, by current standards, yeah, it was extremely slow. But what made Generation 1 truly important wasn't its raw performance. It was the basic idea that a computer could get on the network without being tied to an Ethernet cable. That sounds normal now, right? But at the time, that was the big shift. Wi-Fi stopped networking from being something fixed to a desk, and it started pushing it toward mobility. The problem was that this first version still felt very early. Speeds were low, range and reliability were limited compared with later standards, and it did not feel like the polished home Wi-Fi people think of today. Even early follow-up work inside IEEE was already focused on pushing beyond these original low rates. So, Generation 1 matters mostly because it opened the door. It proved wireless LANs could work, even if the first version was still pretty basic. Generation 2. Generation 2 was 802.11b, and this was the first version of Wi-Fi that really had a reason to exist outside of early adopters. It still used the 2.4 GHz band, but the maximum speed jumped to 11 megabits, which was a huge step up from Generation 1. That change mattered because basic internet use finally became much more realistic over wireless. Email, normal browsing, and small downloads were no longer painfully limited. For many home users and office users, this was the point where Wi-Fi started making sense as something you would actually want, not just something you could show off. Of course, it was still far from perfect. Since it ran on 2.4 GHz, it had to share space with all kinds of other devices, so interference was already becoming a problem. And, like usual, the number on the box looked better than the number you got. Even so, Generation 2 was important because it pushed Wi-Fi into everyday use. It was still basic, still slower than wired Ethernet, but now it was useful enough that people were willing to put up with it. Generation 3. Generation 3 was 802.11a, and on paper, this looked like a serious upgrade. The maximum speed went up to 54 megabits, which was a massive jump from 802.11b. It also used the 5G HC band instead of 2.4 GC, which helped avoid some of the interference problems that were already annoying people on earlier Wi-Fi. That was the good part. The awkward part was compatibility and range. Since it used 5 GHz, the signal usually did not travel as far or pass through walls as well as 2.4 GHz. It also was not directly compatible with the big wave of 802.11b gear already out there, which made adoption more complicated and more expensive. So, Generation 3 was faster and cleaner, but it was not the one that took over homes everywhere. It made more sense in business environments and in places where people wanted better performance and were willing to pay for it. Basically, it was better, but not convenient enough to become the mainstream winner. Generation 4. Generation 4 was 802.11g, and this is the one that really pulled things together. It brought the 54 megabits top speed of 802.11a, but kept using the 2.4 GHz band, which meant it could work more easily with the huge amount of 802.11b hardware already out there. That combination made it much easier to adopt. This was a big deal, because now users could get a noticeable speed upgrade without throwing everything away and rebuilding the whole network. For home Wi-Fi especially, that mattered a lot. You got better performance, better flexibility, and a smoother upgrade path, which is exactly the kind of thing people like once they have already spent money on a router. It still had the usual 2.4 GHz problems though. Interference did not magically disappear, and real-world performance could drop pretty quickly once the environment got crowded. So, yes, the spec looked nice, but your neighbor's microwave still did not care. Even so, Generation 4 became one of the most important early Wi-Fi versions because it balanced speed, compatibility, and cost better than the previous generations. Generation 5. Generation 5 was 802.11n, and this was the first Wi-Fi generation that felt like a major leap instead of just a revision. The top speed went way up, at least on paper, and more importantly, it introduced MIMO, which means multiple antennas could send and receive data at the same time. That changed a lot. Before this, Wi-Fi upgrades were mostly about pushing the ceiling higher. With Generation 5, Wi-Fi also got smarter about how it used the signal. It could work on both 2.4 GHz and 5 GHz, support wider channels, and handle heavier traffic better than the older standards. So this was the point where wireless networking started becoming good enough for things beyond just checking email and loading regular websites. That mattered because home networks were changing. More laptops, more phones, more video, more everything. And this was one of the first Wi-Fi generations that can actually keep up without falling apart the second a few devices got busy. Not perfectly, obviously, but much better than before. So Generation 5 was important because it moved Wi-Fi from basic convenience into something people could rely on much more seriously. Generation 6. Generation 6 was 802.11ac, and this is where Wi-Fi got much more serious about high-speed home internet. It stayed on 5 GHz, pushed bandwidth much higher, and expanded things like wider channels, more spatial streams, and better multi-device handling. In normal language, it was built for heavier traffic and faster connections. This mattered because internet use had changed again. By this point, people were streaming HD and 4K video, moving larger files, using more cloud services, and filling the house with more connected devices. Generation 6 was designed for that kind of load. It was not just about making one laptop faster. It was about keeping the network usable when multiple things were happening at once. The trade-off was range. Since it focused on 5 GHz, it usually did not reach as far as 2.4 GHz, and walls were still walls. So yes, the speed could look amazing when you were close to the router. 2 rooms later, the router had a different opinion. Still, Generation 6 became one of the biggest mainstream Wi-Fi upgrades because it made fast wireless networking feel normal instead of occasional. Generation 7. Generation 7 was 802.11ax, better known as Wi-Fi 6, and later it also expanded into 6G HC with Wi-Fi 6E. This was not just another speed bump. Yes, speeds improved, but the bigger goal was making Wi-Fi work better in busy environments with lots of devices at once. Features like OFDMA, more efficient MU-MIMO, and better scheduling were all aimed at that. That matters because by this point, the problem was no longer just one laptop on the couch. It was phones, TVs, smart home gear, tablets, consoles, cameras, and whatever else was quietly asking the router for attention every few seconds. Generation 7 was built to make crowded networks less messy. Wi-Fi 6E added access to the 6 GHz band, which opened up more clean spectrum and helped reduce congestion even more, especially in places where 5 GHz was getting crowded. So this generation was really about efficiency. Faster, yes, but also better at staying organized when modern networks turned into a small traffic jam. Generation 8. Generation 8 is 802.11be, better known as Wi-Fi 7. This is the newest major Wi-Fi generation, and the headline here is raw capacity. It adds things like 320 MHz channels, 4K QAM, and multi-link operation, which lets devices use multiple bands or channels more intelligently, instead of treating each one like a separate island. What that means in normal language is that Wi-Fi 7 is built for very heavy traffic, very fast broadband, and networks with a lot going on at once. Big downloads, low latency gaming, high resolution streaming, local file transfers, all of that is where it starts to make sense. It is not just trying to raise the top speed. It is also trying to reduce delay and make wireless performance more consistent when the network is busy. The catch is pretty simple. To really benefit from it, you need the right hardware on both ends. And in a lot of homes, that is still the boring part nobody wants to hear. A Wi-Fi 7 router alone does not magically upgrade every phone, laptop, and adapter you already own. Shocking, I know. So Generation 8 is the performance-first generation. For some users, it will feel like overkill right now, but it clearly shows where Wi-Fi is going next. What do you think is the biggest real jump in Wi-Fi history? And are you still using older gear or already on Wi-Fi 6 or 7? Let me know in the comments and subscribe if you want to see more.